Good day everyone, this is Engineer Ganade and I'm going to share to you my expertise in the field of civil engineering. After you watch this video, it will be expected for you, future engineers, to learn the following. Okay, so first let's have an overview of the subject. Our subject for this semester is structural analysis or structural theory. One of the subjects that you should be able to pass before proceeding to a higher year. That is its significance if we just talk about graduating the course. But if we talk about the work, practicing your profession in the future, we can perceive its deeper importance as you go on with the next subjects, in which structural analysis is a prerequisite. So to make it simpler, you won't be able to learn reinforced concrete, structural steel, bridge engineering, or even some topics in geotechnical engineering without a clear grasp of what structural theory is all about. This subject acts as a foundation of almost all civil engineering works. Number 2, let us discuss the main concept and definition of the subject. Structural analysis, the main purpose of it is to determine or predict the behavior of a structure once loads are applied. So it is the study of how applied loads affect a structure. Okay, so we already have the terms loads and structures. Okay, so let us proceed with the elaboration of the terms. We already have the terms loads and structure. Okay, so let us first define what is a load. So a load, determining the loads is the first step in structural design. Okay, so architects are the ones who make architectural designs, but us civil engineers are the ones responsible in making a structural design. Okay, so in structural design you have to ensure that the dimension, the materials that is used, the quantity must be enough to sustain the loads. Okay, so that is our work, our responsibility as civil engineers. Okay, so loads are forces that are applied to the structure. There are forces that can, once applied, they contribute or they make changes, like deformation, deflection, and acceleration to the structure. Okay, so our responsibility as a civil engineer or as project engineer is to ensure that once those loads are applied, the structure can withstand it, or can withstand them. Okay, they are capable of resisting the loads. Okay, so there are different types of loads applied on a structure. So we have mainly the live load and the dead loads. Okay, so let's start with the dead loads. What are dead loads? Okay, so dead loads are also known as permanent loads. Okay, so they are not movable. They are permanent. They stay as time goes by. Sana all. So one of the main example of it is ang weight, the self weight of the structure, or the weight of the structure itself. Okay, that is the dead load. Live loads are opposite of the dead loads. They are those loads that are movable. They are not permanent. They change over time. They change direction and position over time. Okay, they can be there, then after some time they won't be also in that certain place. Okay, so like us, no, those who are occupying the example a building or bridge, the cars, the vehicles, no, they are examples of live loads. But aside from those two, which are the main loads, we also have the wind load and the earthquake load. So these are loads that are applied by the nature itself, no. So it is still part of your design, no. But mainly sa atong subject sa theory, we will be tackling more about live loads and dead loads. Okay. Okay, so another term is the word structure. So a structure is a body or a system that is used to support or carry the loads. Okay, so what are the examples of structures? We have the footing, no? The footing is a structure that transfers the load from the column to the soil. Okay, we also have the column, haligi. Okay, the beams, the girders, those are structures. Okay, natay trusses. Trusses are used in roofs, used in bridges. Okay, we also have frames, the arcs, cables. So there are many types of structures that is used to carry different types of loads as well. Loads which are which acts in a single point, no? There are loads that are uniformly distributed. So ato nga load in previous, that is concentrated load. Okay, so concentrated load, uniformly distributed. We also have tension loads, compressive loads. Okay, so there are many types of loads that could be applied on different types of structures. Okay, so the purpose of structures is to carry the loads. So if there are combinations of different structures, or system of structures, so muna na siya ang buildings, bridges. Okay, maka-form na larger structures, no, in which used for occupancy, used for transportation. So ma-serve na niya ang iyang purpose once na capable siya to carry the applied loads. Okay, so lastly, significance of the subject. So how important is structural analysis in civil engineering? We have this branch of civil engineering which is structural engineering. So like doctors, no? The civil engineering course has branches. You have the specialization also. If you're specialized in structural engineering, so you must master this subject. So it is the integration of science and art of planning, designing, and construction, considering the safe and economical structures. So it is not enough to na safe lang ang imong structure, it must also be economical. So meaning it must not be expensive, too expensive. It must be cost effective. So structural analysis plays a major role, for it predicts the performance of a proposed structure. A flowchart here shows the phases of structural engineering project. Okay, so it starts with the planning phase. As I have discussed recently, in every structural design project, it will always start with the determination of loads. So murag wala siya nagkapareha, no, but um, it shows here that planning phase is the first, but the estimation of loads is the start also of the um, major step, no, the major step in structural analysis, because it will always go back to the estimation of loads every time that your structural design is not sufficient. Okay, so let us discuss the phases. So in the planning phase, it is the general layout and dimensioning of the types of structure to be used. So, or the material to be used is determined. So example, it could be steel or concrete or timber. So that is the planning phase. In the preliminary structural design, so mag-depend siya sa planning phase. Okay, so after the planning phase, the sizes of the various members are estimated based on past experiences and code requirements. So from your previous experiences as an engineer, you will be able to um, assure that whenever you use the same type of material, the same dimension, the same size, so once your previous project is safe, no, there will always be an assurance for the next project that it will also be safe as long as same loads are applied. So, with regards to the code requirements, so natay NSCP, National Structural Code of the Philippines. We also have the Building Code of the Philippines. So your design must always conform with the codes, no? So it is the standardization of the designs. There must be a minimum requirement for every design. Dili pwede gamay ra kaayo or dako ra pud kaayo. So ingana, no, naay mga limits. So diha na to na makita sa codes. So proceeding to the next, we have the estimation of loads. So once you already have a preliminary structural design based on your experiences and the codes, you must determine or estimate the loads. So you will start with the estimation of weight of the structures, the dead loads, and then you must determine also the loads that will act on the structure, that is either the dead loads of those structures on top of it, no, or the loads of the occupants. So mo na siyang mga live sa occupants mo ng live loads, no. The dead load, aside from the self weight, that is also combination of the weight of those structures na gisuportahan niya. So that is estimation of loads. Okay, so once you have estimated the loads, you will proceed with the structural analysis. So in structural analysis, you will determine the stresses, the resultants, and the deflections. Okay? So, once you have determined the stresses, the resultants, and deflections, you can have the safety and serviceability checks. Okay? So, ma-check na nimo if safe ba siya, no? Because there are, in the codes, natay mga minimum requirements. So, ma-check nimo kung nisulod ba ang stresses, ang deflection sa minimum requirement for safety. So, kung pwede, napakay kanang allowance, no, imong padak-an ang imuhang factor of safety. Dili nimo iuntop sa minimum requirement. Okay, what if mo exceed ang imuhang load? So, may possibility nga mo fail na pud ang imuhang structure. So, the results of safe structural analysis are used if it satisfies the safety and serviceability requirements. So, diya nakamutan-aw sa National Structural Code, NSCP. The building code also, makita nimo ang mga minimum architectural designs, minimum requirements. So, once na mahuman ka sa structural analysis, you will proceed to the... So, if it's safe, then proceed to the construction phase. So, ang imong design ma-convert into reality, ma-convert siya into project. So, proceed ka sa construction phase. But if your structural analysis by safety and serviceability check, it does not satisfy, no? So, it's not enough for safety. It does not reach the minimum requirements based sa codes. You will go back to the estimation of loads. So, i-revise nimo ang structural design. So, once na mubalik ka sa estimation of loads, nga mubalik man ka? Because you will redesign the structure. You will change the dimension. You will change the size. You will change the quantity. So, with that, there's also a change in the weights. There is also a change on the effects of the loads. Okay? So, mo ni siya ang the phases of construction design. So guys, that is all for this video, and I hope you have learned a lot. Don't forget to subscribe for more updates sa ito ang subject.